Hey folks, we're back. Been a busy season. So I thought I'd show you guys my next project, which I'm going to get done tonight. So this is my old freezer that I used for beekeeping. It died this spring. I can't really complain. It was a Kelvinator, so I mean, who knows how old it was. Anyway, it ran out of Freon, developed a leak, and went kaput. So I'm going to show you guys how to convert this old freezer into a desugaring unit, which will hold a lot of honey, actually. Might be able to get, we'll see, but I'd say we'll get at least 6 cases of honey, 6 cases of quartz in there, probably more. But I went ahead and, since it didn't have any Freon, I went ahead and cut and removed the compressor, and I've already welded on some little dollies that bring this thing up to a rating of about 300 pounds, which will be good enough for my use. And the compressor area over here, the cover, that's going to be where I put a heating element with a forced air fan. And the idea being is that it will go and blow and circulate all the way around back to here. Now, I don't know about you, but I don't really want to store any food in this freezer in its current condition. So what I'm going to do is I'm going to kill 2 birds with 1 stone. I'm going to get rid of the nastiness, vacuum it out real quick, and then I'm going to add extra insulation. This is an old freezer, so the walls are only 2 inches thick. A modern freezer is, the walls are almost 3 inches thick, so they're much more efficient. So I'm going to do, I have some leftover R panels, and these are rated 3.2 is what they are rated at. You can increase that performance if you've got an air gap behind it. The sides will not, and sides and bottom will not have an air gap, but the lid, which is the most important thing, will. And you walk over here and I'll show you. These lids, this lid, believe it or not, I don't think, it does not feel like it has anything inside it, like foam. I know it's leaking a lot of water because I washed it. I've got it over here by my floor drain, and it's still leaking water. It could have foam in it, but I don't think there is. So I intend to, let me set this over here. I intend to add a piece that will ride right along these ridges, and on the inset, a piece of that foam to help increase the R value. Because, you know, this is a freezer, so they weren't worried too much about the top as much as they were, you know, insulating the sides and the bottom, I guess. Anyway, if you guys find an old freezer that's a more modern one, you know, you won't have to do what I'm doing here. I'm just doing this because, A, I've got the materials, it's free, and the only thing I'm paying for is the heating unit. So basically this, and of course some glue for these panels. So I'm going to get it done for less than 50 bucks, which is not bad. And the beauty of it is that I can keep my honey raw. Honey sugars, and you can desugar it at 117 degrees. If I can heat this thing between 117 and 120 degrees, it's still considered raw honey, because you can have those conditions inside a hive, and it's not going to affect the composition of the honey at those temps. So anyway, we'll be back with this part 1. All right, next step, installing the foam. I'm going to install this with good old-fashioned liquid nails, construction adhesive. You can use specialty construction adhesive, but I'm using aluminum faced foam board, So it has a lot more options when it comes to the adhesives you can use. So you don't have to use just a strictly, they make a foam board adhesive, but it's designed for bare foam. So this stuff at $2 a tube is definitely the economical choice. And since I'm only going to be heating this thing to 120 degrees, it's not really going to have a lot of stress on it either. So I'm just coating every single rib. Get that piece of trash out of there. And as I said before, this is kind of the most important piece. So since my heat loss will occur around this lid the most, I want to do the best at installing it. All right. Find a place to park the gun. And that's, make sure you push it down, and then I'm going to set it down on the floor, foam side down, and I'll use the weight of the lid itself, keep pressure on it. Installation of the walls is real simple. Once again, instead of applying the glue, I can apply it to the actual sheet. Make sure you get plenty in the corners. That's where it's going to want to release more. Well, then we just simply shove it in there and press it in place. Hey folks, well, I got the interior done. Used up most of my scrap, which was great. I've got everything I want insulated. Basically, this is the main storage area, and this is the heat source area, which is why I did not insulate it. It's got, I'm just sticking with the factory metal there. It's thicker gauge, and the fan will actually be mounted right here at an angle and blow on and hit this and then circulate around is the idea. So I know it's going to create a hot spot. And I'd rather have it blowing on that thicker gauge metal. Anyway, we'll be back with the loading of the heating elements next. Okay folks, I thought I'd go over the core of this unit. It's basically a digital controller, 110 volt with a 20 amp 110 to 12 volt power supply, and this little beauty, which is a 100 watt self-contained heater, resistance type, with a little squirrel cage in the back. I went with just 100 amp because I want, this is a forced air heater, and I want the air circulation to be a part of it. So if I have like a 400 or 1500 watt heater in there, well, it's going to spend most of its time turned off. This way, this little heater is going to run more, but it's only pulling 100 watts, so it's pulling nothing. Anyway, and you could heat this with a light bulb or something like that, but honestly, I don't think that's for a project this large. You know, it's real important that I don't overheat things. So it's, you know, kind of critical that my heating is very even and uniform, because I want to keep my honey raw, and I basically want to stay within 3 degrees, 117 to 120 degrees when heating. Anyway, I thought I'd go over and how this thing's wired up, in case some of you decide to build one or another project. Going to use this crappy Chinese grafting tool. Don't recommend anybody buy these. They're garbage. And let me flip this thing around so you guys can read it with me, and I'll zoom in, see if that won't help a little bit as well. All right, so be wonderful to find focus. Okay, so your first two slots are real basic. We're going to go from left to right. First two slots are your sensor. Doesn't matter which order. That's slot 5 and 6. Slots 3 and 4, that is actual power to your unit. So it powers this unit up. So I wound up splicing both my neutral and my hot. So I've got, coming off this power cord here, coming in, I've got basically 2 neutrals and 2 hots. So one of the neutrals and one of the hots goes right up here. And then we have our load, which is, that's what you're actually switching on and off, is the hot side. So I've got the other black hooks into here. The other neutral travels down and hooks to here. So there's my sensor. So basically, and my ground line, let me see, get in there and show it to you. So my ground line is, let's see that little screw back there, that is, there's a green and a yellow line hooked to it. So the green line is coming off of the cord, the yellow line is traveling down right here, and that's my ground. And there is my 2 connections for the powering of this. I've got my hot in slot 1 and I've got my neutral in slot 2. Now these, all of these banks right here, those are all DC output, positive and negative, and they basically are pretty straightforward. You've got all your first 3 screws are volt negative, and your next three banks are volt positive. So basically, I'm going to have this thing hooked up something like this. That's for the heater, and then I'll have 2 more, probably something like slot, second slot and third slot, and that's for the fan. So anyway, we'll get this all mounted up and bring this project to a close. Hey folks, I'm going to show you how to program this unit. Unfortunately, I got a Celsius unit, but I can work around that. There's a set button, a restore, and 2 arrows. Again, the program mode, hold the set button for 3 seconds, and then you can go up or down to different functions. We want to first set our parameter, which is how much it will cool. So you hit, and we want to go down to 1.5 degrees Celsius. All right, so now we want to switch from heating to cooling. And we want to go to heating. And we want to zoom on up to about 47 degrees. And actually we'll go 48. So we should be heating. So let's crack her open and see if she's doing just that. And she is. Yeah. Move. So there's our little heating unit right here, and she's putting out, you know, nice soft heat. And over here is our sensor. So the idea is that our honey, it'll move, it'll hit this wall and run and circulate. So there she is, folks, up and running. With this thing insulated as well as it is, it's not going to take a lot of energy. 100 watts should be enough to bring this thing up to 120 without any problem. Okay folks, we're up and running. There is the unit climbing in temp. I've got her set shut off at 48.5 degrees, which is right at 119. And she's just loaded, so it takes her a little while, but the whole unit, everything is pulling 100 and I believe it's 110 watts, 100 watts for the heater, and then some power loss due to the converter as well as the controller. Anyway, not bad on power, and I think it's a better way to go than like putting a light bulb. If you just put a 100-watt light bulb in, that's a cheap way to go, but I don't think you'll get very good even heating, which is what I'm after, as well as very good controlled heating. So anyway, I hope you guys have enjoyed this video. Please subscribe to my channel, maybe give it a like if you like the video. It'll help motivate me to make more videos. Anyway, thanks a bunch.